really what you're saying is there's been damage in the past. We go, oh, there's damage. There's nothing we can do about that. It's just damaged. But now we think we can do something different to it.
So currently all of the things look at treating the cause, which has had a lot of advancements in being able to treat the cause of the injury so that we stop progression of it. But yes, how can we now treat the injury itself? So there's a lot of different thought processes out in the world about the most adequate way of treating it, and as stem cell therapies, there are a multitude. There's a big cascading tree of different types of stem cell therapies that there are. There are people looking to biomechanic therapy. Can we integrate technology into people to help regain functions and things like that? So there's lots of different ways, and what we're looking at is a very specific type of stem cell therapy that will especially help people who are in this area regain new neuronal functions, hopefully, is the idea behind it.
Okay, so now we've got 2 stem cells. What do stem cells currently do?
Mm-hmm.
And how do you want to change them? Is that the right way to say it?
I guess so.
You're trying to train them to do something different.
So stem cells are the basics for all the cells in your body. All cells derive from a type of stem cell, and there's many different ways that people use them. So early stem cell therapies were using embryonic stem cells. So if you think about a fetus in development, here's a bunch of stem cells. So you'd basically initiate an embryo to start developing, and then you'd remove the embryonic stem cells from that, terminating that fetus or that embryo. And now you can use a bunch of different what's called growth factors or neurotrophic factors, and you can use them to become new cells and tell them basically what people figured out a long time ago is that if you treat cells in a specific way, you can create the desired cell, and then you could possibly implant that cell back into the body, and that cell would become the basis of all new cells in that area in your body. What we've started pivoting towards is, that was the early way, what we started pivoting towards is using your own stem cells. So a very common one is bone marrow cells, or bone marrow cells from somebody else with a similar genetic heritage to you, because that matters in terms of rejection acceptance. And using those cells to, let's say, if you had a blood disorder, moving your bone marrow, putting new cells back into your bone, or new stem cells into your bone marrow, which would then populate the area, and they're healthy cells that produce the correct types of blood cells and red and white blood cells that would then populate your body and help you regain function. What that involves, though, is removing cells and putting them back in, which has its own issues with acceptance and rejection, and that's leading problem in actually progressing these types of treatments. So the other school of thought is, how can we manipulate or use the remaining stem cells that are already in your body and retrain them to become new cells? So specifically in your spinal cord and your nervous system, there's a type of cell called neuroprogenitor cells, and in early childhood or early development in the embryo, they become new neurons. And as we get older and we leave early development, they start becoming all your neuroprotective cells. They still remain in your body, but they stop having such an influence in creating new functional neurons or new functional nerve cells. So what we aim to do is use, similar to what we would do if they were outside the body, is use a certain combination of factors that will hopefully divert those cells from becoming neuroprotective cells and teach them to, or tell them to become new neurons. So we're trying to reprogram your internal cells to become new neurons and replace the lost cells that have been lost due to the damage that occurred. And then once that has happened, then hopefully you can regain function within the body.
Well, that sounds amazing. You see, I've like glassed over the black one. I'm keeping up. I think I understand what you're saying. So that's the goal of what you want to do.
Mm-hmm.
And you've had some success with this?
Not really.
Right.
So there's a lot of variables in science, and what's happened over the last few years, we've made a lot of success in modeling the disease or developing models of the disease so that we can accurately figure it out to one point. And what we've had trouble with is what we call our ex vivo analysis, where we look at these cells in isolation outside of the body, and they're famously hard to grow. And so what we've had trouble is looking at them in that environment. And then in our models of the body is we've had trouble with doing combined treatment, because not only are we looking at the healing the damage that's been done, we're also looking at the initial treatment, which in our case is removing the compression and then trying to treat. We've had troubles with that part of the model as well, which has been compounded by our lack of funding. So we don't have a lot of funding to really expand models and our understanding and try different techniques. We're very limited in our resources. And so we've tried to make the most of them, but really it's hard to progress when we don't get enough funding to have a fully encompassing research model.
And is there other people in the world doing similar research to this who potentially may have more funding that can kind of help you push along what you're doing as well? Or is really the answer to try and get some more funding?
There are other people in the world who try or have tried similar models and tried similar things who have had early success, which is why we've tried to mimic it. And they've looked at mostly traumatic injuries and the response to traumatic injuries with it. However, what seems to be very ubiquitous problem is a lack of funding in this field and of availability of funds.
And what's the answer to that, other than obviously to get more funding? But how, so the implications around what you can do to help people with these injuries, I guess people with money are thinking like what is going to have the most impact, so what's going to affect the most amount of people. And whilst this is a growing and important problem around, you know, people having lack of mobility and a lot of other issues, if you were to have success in this model, does it also then have, because it seems like it would have ramifications across a lot of disease, not just this?
Yeah, so if the type of treatment we're trialing would potentially be very applicable to many types of diseases. Funding changes need to happen, I think, firstly at a government level, and relying on philanthropic investment is probably the downfall of a lot of research, because that is going to be very targeted to issues that affect probably the people who are making investments, which can be quite niche and is often, there's a broad spectrum of disease that affects people who aren't able to have those impacts. But namely the government level of research funding is what needs to be targeted, because recently there's been a cut in research funding in Australia and around the world that impacts a lot of research. And I think people don't trust research in a sense, or they think that research can go on without this funding. But what they don't realise is research is very expensive, and a lot of the expense goes to hiring people to actually do the work. And so as we cut research funding, we cut the ability for people to hire them. And a lot of those people who would love to do research end up going to industry, which is privately funded. So we're looking at pharmaceutical companies and private companies that obviously have an agenda around trying to monetize those, or how do we, one, fixing an issue, but also they need to be able to recuperate the costs. If we have more government funding, that will lead to greater research capabilities for people who are already doing research, because they can expand their field, they can have more advanced equipment and more advanced tests, they can have more advanced staff to do the work. Whereas right now, a lot of research, especially in Australia, relies on PhD students and honours students to do the grunt work, and then you have some higher seniority people, but there is a drastic lack of funding that would need to be addressed first to actually be able to progress any research in Australia.